All right, so ITS148, 148, we are, let's see, this is April 11th, and we're going to start we're going to start the chapters on databases, and chapter 16 is like not too much in that chapter. Let's see, you guys that are taking the database class, how much into normal forms do you get? Do you guys learn about second normal form, third normal form, fourth? Okay. Yeah. BCNF is as high as you go, though, right? You don't go to fourth or fifth or anything. 3NF and 4 and BCNF. Oh, that's good. So we might be using some of that. So I'm gonna pull down the PowerPoint slides for chapters 16 and 17 today. And it looks like we're running out of thought space. And I still got to put up I'm falling behind on my quizzes. So I'll put up some more of those quizzes up. I've changed the format. Oh, me. All right, I'm going to share my screen. I've started recording. I'm going to share my screen. Share. All right, I'm sharing my screen. So I've changed the quizzes. Or I've learned more about how to set up these stupid quizzes, and it used to be that you could. It used to be that you can take them as many times as you want, but you weren't able to know which questions you got wrong. So I've changed it. So you can only take it 3 times, but now there's this assessment thing where you're able to see. These are the earlier ones, but on the later ones, you're able to see exactly which questions you got wrong. And of course, if you're clever, you can copy all that down and just focus on those questions you got wrong. It says which questions you got wrong. It doesn't say what the right answer is. But if you can take it 3 times, that's enough. That's okay. It's 1 short of. If you're really unlucky, then you get points. I thought about making it 4, but that's kind of too much. I don't know, but since they all just have four answers, so it's like you get 3 chances to answer each question, kind of like that, and you know which ones you got wrong. So that should be easier. So it should take a shorter time for you, and then I found that it doesn't really happen in this class. It hasn't happened in this class so much, but in the other classes I teach, people. Well, actually, it has happened in this class sometimes, where they think they got the one they got wrong. They don't think they got that wrong, but some other ones they think they got wrong and they got right, and so they spend their time on the wrong thing, and that's. I mean, I like doing things where you spend more time in my class, but not inefficiently and focusing on the wrong thing. Of course, that doesn't help anybody. So anyway, I just thought I'd mention that. All right, so I'm going to start. Let's see how far we get with some slides, and then I'm going to try to do exercise 18-1, which is a real quick database. So when you guys do your so you use SQL Server, use Microsoft SQL Server. So what application or what environment do you use? Do you use Visual Studio? Uh-huh. Okay. So it's an SQL server, and then you just type in SQL statements, and you just. And so, did you use any kind of programming language to did you connect the database to any kind of programs? Yeah, Mongo though is still a database language, right? It's not only SQL. So R R Python. Yeah. All right, because we're gonna we're C sharp. We're gonna connect MS SQL to C sharp. All right, so let me just go. So maybe I can go through these slides pretty quickly. Then let me see what we got here. Go to cost base, and let me see what's in 16. I'm not sure. Chapter 16 is a pretty nothing chapter. Oh, not this chapter. No, 17 and 18. Let me bring down 18. So really, let me do a code here. So really, this should be something more like 17 and then 18, 18, 19, 19. And then what is the 20, I think is the last. Yeah, 20. More like that. All right, so yeah, one day on 17 is fine. Okay, so let me get rid of this. Uh, all right, introduction to database programming. Describe the hardware components of a typical multi-user system, typical multi-user database, how the table and a relational database is organized, relational databases, how tables and a relational database are related, SQL statements, select, insert, update, delete. All right. Database server, you know this stuff already. Client server, client SQL queries, database server, database management systems. All right. How a table is organized. Let's see, have you taken 129 also? Oh. Oh, okay. But we're pretty far into the semester. So you know what tables and fields and columns and all that stuff. Okay, but maybe maybe the people out there don't know as much. Where is it's like, where's my, I don't know why this thing is not showing. Why does it say start Zoom? I don't get it. I don't get it. Oh well. It's like something's messed up. Well, I hope it's recording. It probably is. Okay. All right, so I'll slow down a little bit. Most tables contain a primary key that uniquely identifies each row in a table. For example, in this table here, you see that there's this product code column, and the idea with a key is that it's unique to every row. So you can identify the whole row just by saying what the key is, what the product, like for example, product code. And so when we talk about CS15, product CS15, we can refer to all this other stuff too. All this other stuff comes along, the title, the description, the unit price, and the quantity on hand. That all comes along with that. And also you use this key if you want to sort of connect it to other tables too. You may have another table that's got courses. You might have a table that's got courses. And in the course table, you might have the textbook for the course. And so in the course table, you can have a textbook for the course, and that can be this product code. So you might have like CS15 in that field in this other table that's courses. And then so if you want to know, so if you have a course like ITS148, and you want to know that the book, the price of the book in this ITS148 course, you don't have the price of the book in the ITS148 in that table, but you do have the textbook product code, you have CS15, and so from there you can get to the unit price for the textbook in the ITS148 course. And that's what kind of this is all about with foreign keys and primary keys and all that kind of stuff. So we have columns, and that's we also can call them fields, and we also can call them attributes. So columns, fields, attributes all means the same thing. We have records, and we have rows, and we have tuples. All means the same thing. When we talk about attributes and tuples, that's more the relational algebra terminology. Is where this whole thing is called a relation. It's called a relation, and we've got attributes here, and we've got tuples. There's four poles, whatever. So here's an example of two related tables where we have invoices and invoice line items. Okay, so this is a little different. Okay, we've got an invoice ID, invoice line items, invoice ID. Okay, good. We have an invoice. We have invoices here. This top one is invoices, and we've got an invoice ID. And this invoice ID is the primary key. So there's only one row that's got a 41, only one row that's got a 42, one row that's got a 43, one, and so on. And for each invoice, there is a customer, a single customer, and there's a single date, and there's a single product total, and there's a single sales tax and shipping and invoice total. There's a single one for each of these. And then we have down here, we've got this line items table. And this is a little different. You see, we've got we have you notice here we've got 3 of them have invoice ID 46. See, so that's because invoice 46 over here has got 3 line items in it. Oh, it's got 4 of them. 1, 2, 3, 4. So there are 4 line items in invoice 46, and there's a different line item for each. So uh, in invoice 46, whatever invoice 46 is, it contains this book, which is A46B, and this book BBR2, and this book SQ12, and this book BB15. See, so it's got 4 different products. Now, now if somebody was buying more than one of a product, we do not add a second invoice line item. That's taken care of by the quantity field. Okay, like for example, this one here in invoice 47, this guy wanted to buy 2 DB2R products. I mean, 4 of them, wanted to buy 4 of them. See, so what we can sort of conclude or hypothesize from this database here, this whole thing is called a database, it's got 2 tables in it, is the primary key for this table would be the combination of the invoice ID plus the product code. And so the invoice ID plus the product code will uniquely identify one row. The idea is you want your primary key to uniquely identify a row. And so you take up as many columns as it takes. You combine as many columns as it takes, where that will, by definition, uniquely identify one row, and that is called that's a key, or it's a candidate key. It could be called a super key also. Different terminology there. So how tables in a database are related? The tables in a relational database are related to each other through their key columns. A column that identifies a related row in another table is called a foreign key. Okay, so in here, this invoice ID is a foreign key because it identifies a key column in this table. In this table, invoice ID is the primary key. In this table, the primary key is invoice ID plus product code. Those two key values, those 2 columns together make up the primary key. And oh, by the way, customer ID here, that's pretty obvious. This is a foreign key, customer ID, into another table of customers. And in that table of customers, the customer ID would be the primary key. 1 customer ID per row and 1 row per customer. So usually a foreign key corresponds to a primary key in a related table. In SQL Server, however, a foreign key can also correspond to a unique key in a related table. Well, that's very liberal of it. In my experience with databases, SQL Server is the most restrictive. A unique key can also be it's usually a candidate key, which means it could be the primary key if they chose. It's just up to the designer and usage. For example, for here at UH, we have this 8-digit UHID, 8-digit ID, which is your student ID. But we also have our up to 8-character, ID that's used for our email. And everyone's got one of those, and it's unique to the person. And everyone's got an 8-digit ID that's unique to the person. We have instructors have 8-digit IDs too, and I'm quite sure in the system the 8-digit UHID is considered the primary key. However, the uh, uh, the uh, the username email username is also unique, so that can be um, that can be that can be used as a foreign key in some other table. And in fact, in Laulima, we don't see in Laulima I don't see your 8-digit UHID. I do in my UH. So we have this Server Explorer Design View window. You might have probably seen that before. We also see that in Visual Studio. And so we have the keys over here, PK invoices, primary key invoices. Invoice ID is that. We don't seem to have any constraints. We don't have any indexes. Indexes are usually used for, well, they help sort. But we do have some foreign keys here, and customer ID is a foreign key. So we see invoice ID is the primary key, and then we've got a customer ID, and then we've got these other things here, which are none of which are keys or candidate keys. So these are some SQL Server data types, which you probably are familiar with for those of you that have taken database. It's similar to Visual Studio. We got bits. We've got these char type data types, and they all have to do with characters. They're different in various small little ways. They're different in small little ways. Varchar can be variable number of characters. Char is a fixed number of characters, and so on. We've got date, time, variable types, data types. We've got decimal and numeric. We've got float and real. We've got these various integer data types, same as in Visual Studio, and representations of currency. So here's this MMA books database. What does that stand for? Mike Muroc Associates or something, I bet. Mike Muroc. Whatever. So this is pretty typical. We've got customers. You see this. It's what we talked about earlier. We've got the customer. We've got a table of customers. The table of customers. We've got a table of invoices. We've got a table of invoice line items. We've got a table of products, and we've got the state code. We could also have a zip code table, because a zip code will define a city. There's no zip code that shares two cities. There can be a zip code. A city can have many zip codes, but a zip code can only have one city. So we should actually have another. Okay, so let me ask you guys that have taken databases before. See this customers table? What form is that in? Assuming that the zip code can define the city. What form is that in? Well, it's not in BCNF because we have a city depends on zip codes, so we've got a dependency between two non. It's not in third normal form because we've got two. Well, it is first, definitely first. It's first. And we also know that it is in second normal form if if it's in first normal form and it only has a single field as a primary key, then for sure it's in second normal form. And in third normal form, you cannot have you cannot have a non-key attribute or a non-key field dependent on another non-key field, and here you do, because city depends on zip code. Yeah, but nobody ever nobody ever you hardly ever see the zip code and the city field separated out into a separate table. Although they might be doing it now, because a lot of forms, a lot of web forms that you fill out, you type in the zip code and the city pops in. So they must have something in there that does that. I think that's right. I can't remember. Yeah, so that would not be in third normal form. Third normal form. Got to be in second normal form. And every non-prime attribute of R is non-transitively dependent on non-prime attribute is an attribute that does not belong to any mechanic keys. Expressed differently, its definition. To this 3NF table, but fails to meet the requirements of, it's 2NF, fails to meet the requirements of 3NF because winner date of birth, because this depends on this. Yeah. So you got to split it up and do this. Yeah. Or it's actually both these together. Yeah, and they don't have anything to do with the key. Anyway, so that they're second with normal, not third. Okay, anyway, that's yeah. All right, so okay, so in one thing nice about the SQL database language is that it's not going to change. I mean, it's SQL database language is going to be the same now as it was back in as it probably came about, what, in 1980 or something, 1990 or something. Let's see, 1980 maybe, and it hasn't changed. C# is going to in 20 years, we might not, well, probably still have C#, but there's going to be plenty new languages, you know, but will be shipped around from different languages. Python and PHP and C#, they all came around the same time, but now all of a sudden there's this big, huge interest in Python. And the reason is because stuff gets added to the language, which sort of makes it relevant again. Anyway, so the way the select statement works, as you know, is we're selecting, these are fields, from a table, and then there's this selection criteria, this restriction, which restricts the number of rows that you get back by some expression. And then, of course, you can order the rows that come back by the column, by the values in the columns in some way. So so you have a select, and you're selecting which columns, and if you don't select all the columns of the table, you know, then it's called a projection. You're only projecting some columns of the table, and then you have the table here, and it's possible to join the tables. We'll get into that. You've had that. And then this thing restricts the rows that come back. Like, for example, you may want to select all the customers. You may want to select all the invoices less than $100. So the restriction would be product total less than 100. These guys are trying to call me all day. Shoots. You may want to do. You may want to select just the invoice IDs and the customer IDs of all the products of all the invoices that are less than 50, or that are less than $100. And so then you would say, you know, select invoice ID, customer ID from whatever that table was, invoices table, where the product total was less than 100. You can also, well, we'll get into that later. Join. Get into that later. Okay, select statement that retrieves and sorts selected columns and rows from the customer table. Okay, so here, so we have this customer table, and here, for example, now the customer table's got a lot of stuff in it. It's got customer ID, name, address, city, state, zip code. However, here we're just going to select the name and the city from customers. So that's a projection. We're just going to look at name and city. And the restriction is we're only going to be looking at states that are Washington State. That's WA, right? So we have this restriction here referring to a column that it's not involved in the projection. That's okay, nothing wrong with that. We're only interested in name and city. And we're ordering by name, which means it's sorted by name. So if you don't specify a direction in the sort, it's ascending, low to high. You can also specify descending, which means it would be high to low. So to query a single table, the result is going to be a result set. The select clause lists the columns to be included. You can have things called calculated columns, where you actually have an expression in there, and it does some sort of calculation. So it displays, when it displays out, it looks like it was a column, but really it's not. The from clause names the table, and you can join tables. We'll get into that. The where clause is the restriction that specifies which rows to be retrieved, and the order clause defines the order that it displays out. If you're satisfied just seeing all the columns, you can put an asterisk in there, and that way you don't have to remember what the column names are. So this is a very simple select statement. You want to see all the customers. You want to see all of the fields of all the customers. So we can join tables like this. This is a complicated join. I don't use this too much. I just use equal most of the time. So here we want to connect two tables together based on some columns. And so an example of that would be like this, where we want to see this is kind of what I was talking about before, where we have this invoice. Wait a second, this is not. Well, this is all just, oh, products. What are we getting out of products? Oh, product description. Is a product description in this thing here? Oh, just product code. Oh, oh, this is actually. Oh, there's no product description here. There's no. Oh, here. Oh. Here's the products. This is the products table. It's got a product code, product description, and then we have this is the product code here, which refers to this. Okay, so what we're doing here is we want to see some more information about a particular invoice. So we want to look at the line items for a particular invoice, particularly invoice ID number 46. So we're looking basically at the invoice line items table, and we're only looking at the invoice line items for invoice ID number 46. So that right away means that we're only going to see these 4 records here. But if we were just going to look at the 4 records, this right here is not enough because we don't know what the books are. We don't know what the name of the products are. We would like to also know the names of the products. And so to do that, we join the products table, but we have to tell it, how to connect. I mean, how to like what the connection is. We have to say, we have to tell it what the key, this sort of primary key, foreign key matchup is. And so we want to say the product code in the invoice line items table is the same as the product code in the products table. And so once you do that, we can project anything that's also, or anything that's in either table. So up here in this select clause, in where we list the columns that we want to project, we can actually list anything in invoice line items and in products. So that can include any of these things. And so we are, in this case, we're interested in the invoice ID and the product code and the description, the unit price, and the quantities, or anything that we're not interested in. Item total and quantity on hand. So we're leaving out item total and quantity on hand, because there's no item total and there's no quantity on hand. And so join lets you combine data from 2 or more tables into a single result set. The most common type of join is inner join. This type of join returns rows from both tables only if their related columns match. So the syntax of the insert statement, there's selecting, which displays out. There's inserting, which you want to put some rows, 1 or more rows in. There's deleting, where you delete 1 or more rows. And there's update, where you update 1 or more rows. There's some other variants also, like replace and so on. But replace is actually, delete, insert kind of thing. So the syntax of an insert statement is insert into table name and then when you insert, you don't need to specify something for every single field that's in there. So you can put a column list there and say you're going to insert into a table and you're going to specify these columns, and the rest of the columns we're just going to just use the defaults. So when you define a table in SQL, when you define a table, you want to define defaults for every single column. Now those defaults can be null, but which means that when you're inserting something into a table and you don't specify what it is, the result is you're actually putting a null in there. Null is not the same as blank. It's not the same as 0. Null is kind of peculiar because if you're going to do a where, if you're going to do a restriction, and you're going to and you want to include a field that has null values in it, you don't know what's going to happen. That it may be included, or not. And so we always discourage using null values in databases, but sometimes you can't help it. And you certainly cannot help it when you're doing different kinds of joins. Like I've done a lot of database stuff, and I use left join the most. Why? Let's say I've got a list of voters. I got a list of voters, okay, and I got a bunch of information on voters, and then I also have a list of phone numbers for voters. But I don't have all the phone numbers for all the voters. But I want to produce a table that's got name, address, phone number. But I don't have all the phone numbers, but I still want to list the voters that I don't have the phone numbers for. So I do a join, and I do a left join. I do a join on voter file, left join phone number file on the voter code, the code for each of the voters, and then what comes up is going to be a big table, and there's going to be a phone number field for every voter. But if I don't have the phone number for a particular voter, it's going to end up being a null. It's going to be null. So in the results of a selection, in your results set, you oftentimes can't avoid nulls. But when you're defining, when you're inserting, that kind of stuff, you want to try to avoid nulls as much as you can. So in this format, in this form of an insert statement, you insert into the name of the table, and then we're going to insert these values. We're going to insert a value for product code, description, unit price, and quantity on hand. And then you have this values keyword here. And then you, didn't mean to do that. And then you list the values corresponding to those field names in the same order. Okay. Now, in a regular table, in a regular relation, when you talk about relational algebra, the rows, the order of the rows don't matter. and the order of the columns don't matter. You can have two different tables, and the rows are in different order, and the columns are in different order, but the tables can represent exactly the same information, and the order of the columns and the order of rows don't matter. However, in SQL, when you're doing this kind of stuff, it does matter because of stuff like this. Okay. Now there are other variations of an insert statement where you would say insert into products, product code equals CS15, description equals Merox C# 2015, comma, unit price equals 5650, comma, quantity on hand quantity equals 3000. Okay, that's another variation of an insert statement, which is valid in many SQL. Is it valid in? Oh, okay. Yeah, MySQL. The other interesting thing about this example is you notice when there is a single quote in the data, single quote is used to delimit, or it's used to enclose, to define to enclose data. So you do two single quotes in a row, kind of like Excel. Update is similar. You say update table name, and then here you use a set like this. Okay, in MySQL, this can be insert into products set like this, and so you can have as many as you want. There, comma, something else, comma, something else. And then you also have a where clause. You also have a restriction. Very important. I don't think they should put, for update, I don't think they should put the where clause at the end because I used to do this. I don't do it anymore. But you accidentally leave off the where clause, boom, every single record gets updated to something that you don't want. And there's no undo. In SQL, there's no undo. You have to, when I first started writing SQL code, I would like always make a copy of the table before I'd start doing stuff, just because I didn't trust myself. And I've blown it before. And then there's delete from table name, and then you have a where clause. It's you usually don't forget the where clause and a delete because it's so short. This is all it is. You don't specify any columns or fields or anything in a delete. You just specify the table, and then you specify the something which describes the kinds of rows that you want to delete. And it's usually something like this, where you want to delete a particular customer. So in this case, you're deleting a single customer from a customer database. In the invoices ID, or in this in invoice items table, you might want to delete all the invoice items for a particular customer. That may be more than one record, but just because there can be more than one record with the customer ID of 558 in the table, but it's usually not much more than that. Okay, so in .NET, we have these methods here that are used to connect your C# program to the database. There's a connection, and that basically just identifies the path to the table, to the database. There's a command which would include as an argument some SQL statement, and then there's a data reader which in data reader and data adapter, which in C# you read a chunk of data from the database into a data set that's not the database, and then you make you do all your stuff in the data set, and then when you're done, you want to update the database with what you changed in the data set. So these things sort of help you do that. So these are the data providers included in .NET. We're going to use SQL Server. But there's these other ones too for other kinds of databases. And class names for the data providers. We're going to just use SQL Server pretty much. This is how the basic ADO, it's called ADO.net. This sort of a diagram of it. We've got the database, the data table. This is what we manipulate in C#. Then it goes through these .net methods here and connects to the database there. And so with the database server, you can have more than one user messing around with the database at the same time. And so there are techniques to make sure that one user doesn't, there's techniques to handle concurrency, basically. Concurrency concepts. When two or more users retrieve the data from the same row at the same time, it's called concurrency. Because ADO.net uses a disconnected data architecture, the database management system cannot prevent this from happening. If two users try to update the same row in a database table at the same time, the second user's changes could overwrite the changes made by the first user. Whether or not that happens, though, depends on the concurrency control that the database programs use. In ADO.net, we use what we call optimistic concurrency. Have you guys heard of optimistic concurrency? Okay, what that is the program will check to see if the database row that's going to update has changed since it was retrieved. So, for example, let's say you're going to update the customer record. Well, you're going to update customer record number 55. So the first thing you do is you grab out the entire customer record 55, and that's what you mess with. And you remember the original values. And then you make your changes and stuff. And then you say, okay, now I'm going to update the database. And so just before you update the database, you make sure that the current value, the values in the database just before you update, are the same as the values that they were just when you took them out. If they're not the same, that means someone else came in and messed with it while you were messing with yours. And so then your update is rejected. You say, sorry, you got to do it again. So you take it out. So by optimistic concurrency, the reason it's optimistic is because you're optimistic that no one else has changed it. So you don't bother to lock it out or anything. There's other kinds of concurrency where you say, okay, I'm going to update customer record 55, and you say you put a lock on it, and no one else can touch 55 while you're messing with while you're doing your thing, and then you're done. You write it back out again, and then you release the lock, and then everybody else. That's a different kind of concurrency. ADO.net does optimistic concurrency, which I prefer. When you're making and in fact, when I teach, web database updates, the web's got that problem all the time because you can have, a bunch of people out there trying to buy the same item on Amazon or whatever, and so you actually have to program that in, whereas ADO.net it's sort of built in. If optimistic concurrency is not in effect, the program doesn't check to see whether a row has been changed before an update or deletion takes place. Instead, the operation proceeds without throwing an exception. This is referred to as last in wins, because the last update overwrites any previous update, and this can lead to errors in the database. How to avoid Concurrency errors. For many applications, concurrency errors rarely occur. As a result, optimistic concurrency is adequate, especially in the stuff we're doing, because your database is on your computer and you're the only one that's using it. If concurrency is likely to be a problem, a program that uses a dataset can be designed so it updates the database and refreshes the dataset frequently. That way, concurrency errors are less likely to occur. Another alternative is to design a program so it retrieves and updates just one row at a time. That way, there's less chance that two users will retrieve and update the same row at the same time. And so this is the dataset object hierarchy. Makes a lot of sense. Table, columns and rows. Constraints. The constraints have to do with things like, like in this table, like in this situation up here, the constraints. Okay, so you may have referential integrity constraints, where let's say you come along and you say, or no, let's say you have a customer table. Let's say you have a customer table, and you got these customers, and you say, that customer number 333, he's a jerk. I don't want to see him in my system anymore. So you delete customer ID 333 from the customer table. Well, guess what? There's a reference to customer ID over here in the invoices table. Well, that's going to cause a problem, because now you got customer ID 333, and it's a foreign key, and it's a foreign key into nowhere land, because there's no primary key in the customer table anymore that's 333. Or let's say here you want to delete, you go, oh, invoice ID 33, the guy canceled. Okay, so let's just delete invoice ID 43 out of here. Well, you do that, there's a problem, because you still have this other table here that's got 43 in there. Okay, so there's two ways you can handle it, and it's easy to pick which way you want. You think about it, pick which way you want. If you want to delete invoice ID 43, either it won't let you do it because otherwise you'll leave this orphan. Okay, either it won't let you do it, or if you delete 43 up here, it's going to delete all the 43s every place else. So you want to either cascade your deletes or not. So anyway, we'll get into that. All right, it is 2:58. I guess I didn't get a chance to do any demonstrations. We'll do that next time. Any questions? All right. Thanks for watching.